We continue with question number 8. A centrifugal water pump rotates at 800 RPM, and all the parameter is given here. We have B1 50 millimeters, B2 25, R1 40, R2 125 millimeters, and we have beta and beta 1 and beta 2 45 and 30 degree respectively. So, and then assuming no angular moment of fluid at the blade entrance, so this means that there are no uh, V1 actually. Okay, so and then please determine the ideal flow rate, okay, the pressure head rise across the impeller, the theoretical torque, and the power requirement. So in this question, I hope you could try to imagine. Sometimes we will give you a diagram of pump, and then we will list all the elements. So you need to solve that problem by using that element. Okay, so if we list down all the elements like this, it doesn't mean that you need to use all these parameters. Maybe this parameter is just to show the specification of that pump. You may use that numbers, you may not use that number. So please be careful, because sometimes students would like to use all the numbers given in the question. Not all the numbers given in the question need to be used to solve the problem. Okay, please use only the necessary properties to solve problems. Okay, so we have 4 questions here to be answered. Okay, so first, as I said, it is advantage for you to draw the velocity triangle. So this is the velocity triangle. So this is the rotational. So this is the rotational speed. The omega here. So and then we draw the velocity triangle, and then we need to calculate the ideal flow rate. So again, it is advantage for us to calculate the value of U1 and the value of VF1, because these two parameter is actually can be directly calculated from the equation. So U1 can be calculated, and it is about 3.35 meter per second. So and then VF1, so you could see that because we have a 45 degree here, and we have, so because we already know the value of U1, so we could get it is equal to 3.35 meter per second. So and then we could calculate the value of Q by using VF1 pi D1 B1, which is equal to 0.0421 meter cube per second. So again, so here, so you need to understand that this equation is actually from the idea of Q is equal to A times V. So and then I already explained to you, okay, the idea of cross-sectional area here. So it is actually reflect the pi dB here, because there are no information about the thickness of the blade. So it is okay for us to use K is equal to 1. Okay, 0.1. So and then we calculate the pressure head rise across the impeller. So the pressure head rise across the impeller is actually reflecting the Euler head. So this is the equation for Euler head. So we need to determine what is the V2, what is the U2. So again, these two parameters is the simpler one is the value of U2, because U2 can be calculated by using equation. So this is the equation. You substitute everything, so you will get it is 10.47 meter per second. So and then VF2 can be calculated by using this equation. You will get it is 2.14 meter per second. And then the value of V2 can be calculated by looking the velocity triangle here. we have a 30-degree opening here. So, and then you will get a 6.76 meter per second. Using all the parameter here, you will get the value of Euler head is 7.21. So, and then the theoretical torque. So the theoretical torque, so this is might be the first question asking you about the torque. You could refer back in our lecture notes about the Euler head, because we start the derivation of Euler head with the calculation of torque. So this is the equation of torque. Okay, because the V11 is equal to 0, we could simplify this term. So this term, it will become to 0. So we only need to calculate what is V12 and what is R2. R mean the radius at point number 2, mean radius at the outlet. So you could substitute all these parameters, you will get the torque is 35.6 Newton meter. And then the power requirement. So this question might be a little bit tricky, because normally we calculate the power with rho GQ HE. Okay, in this situation, you also could calculate with rho GQ HE, but you may calculate the power by using this equation sometimes. Okay, because we already know the rotational speed, and we already know the torque. Okay, so and then the rotational speed can be calculated by this one. So we already know that U is equal to R omega. So and then we could determine the omega if we know the value of U and the value of R here. So and then it is equal to 83.76 radian per second. So the total power for this system is 2,982 watt.